Good evening, good morning, depending on when you're watching this. I'm Akash. I am a master's student in the Simulation and Visualization program at NTNU Olesund. Uh, I'm sorry I'm having a sore throat, but please excuse me for that. Anyway, so we'll be going through the Eden cluster today and basically how to interact with it. Uh, My earlier interaction with the HPC was done using a Linux terminal, but I soon realized that researchers might not want to fiddle with the terminal a lot, and hence I looked for, I would say, more feature complete solutions for the scholars. So, if you go through my article, I've listed down two approaches which can be used separately or together depending on what you want to do. MobXterm is a good solution, which I'll be demonstrating here. But MobXterm kind of makes more sense if you don't want to edit your code once you have uploaded it to the cluster. Hence, this is the approach that I won't be kind of exploring a lot. Feel free to use it if you find it more, I would say, apt towards your situation, right? Uh, yeah. So when you open MobXterm, this is how it would look like, and ideally, I mean, if you just started MobXterm, then you wouldn't have things like this. You would have something like this, like you create a new terminal, and then you would do something like this, which will be Eden HPC NTNU, and then you basically log in using your normal SSH command. What I would suggest you guys to do is you go to sessions, click the star, right click here and create new session, and then click on SSH. Here you will be writing the the machine's URL or IP address depending on what you have, Eden HPC, and you will write your username. In my case it will be Akash SM, and you basically click OK, and it creates a new session for you. It might ask you for the password one time, and then again, if you don't save it, if you save it, it doesn't ask you anymore. So in my case, I'll just log in by double clicking, and as you can see, I have logged in. My password was saved here, so it worked out of the box. There are a couple of details that I would talk about soon when we go back to VS Code, or rather go to VS Code, because that is something I want to cover in more detail. Here in this case, that is it basically. So we have logged in, and as you can see, I am in the cluster login node. So the steps from here will be pretty much the same that we'll be doing in VS Code. So now we'll move on to VS Code. If you have any questions regarding MobXterm, feel free to ask me. I mean, in context of deep learning or the Eden cluster, of course. But yeah, so I'll just go ahead and close this session because it's a good thing to do. And yeah, that's it. Now we'll go to VS Code. By the way, in my blog, I have mentioned that you can log in into your login node from outside the campus, or rather outside the campus network. That is definitely something that's possible, but I wouldn't recommend it because there is an extra step involved, and not just in terms of steps, but rather in terms of another machine, which is like a man in the middle for you. A lot of things will get complicated if you do it that way. So I just recommend that. I mean, that's the same thing I've written in the article. So my recommendation is just to use the VPN that NTNU provides, which is the And the software they recommend is the Cisco AnyConnect software that I'm using here as well. So you just log into the to NTNU VPN network, and then basically you are like, it's as if you are sitting in the campus, basically accessing the campus network. So you won't have any problems then. It will be like straightforward, very, very straightforward. Also, I forgot to mention that on MobXterm you can directly copy things over and download if you want, using the file explorer on the left. Sorry, I did not go into detail because like it's pretty self-explanatory. So if you have any questions, feel free to ask them. Okay, so with VS Code installed, there is one extension that you would need, which is the SSH remote SSH thing. This is like a really useful tool, because in this you don't have to install anything on the other machine. Okay, everything is done over SSH, which is pretty neat. You don't have to set up another VS Code server on the other machine or anything like that. So it's very neat, and it's extremely robust. So the way you connect to the cluster is by clicking here. It says open a new connection. So you can click connect to host, and if you click on this, it will ask you to basically enter this command, which, if you remember, is very similar to something that you would enter in your terminal if you were trying to SSH using the terminal. So you would just write SSH, your username, at Idun login, whatever the URL is, and then -a. I've already done that, so I don't have to do it again. So I can press escape, go back, connect to host, Idun HPC. It opens in a new window, and it will ask me for the password, which I have saved already. So I'll just enter it, and that is okay. Yeah, sorry about that. Apparently I had the wrong password copied. Anyway, so now that I'm logged in, as you can see, like as soon as you put your password and hit enter, this is the first thing that you'll see. So I promise I haven't skipped anything. And here it will exactly tell you what which machine it is logged into. So I'm currently in the Idun HPC NTNU URL that I used to SSH into this, and what I'm logged into is the login 1, which basically tells me that I am in the login 1 node. There are 2 login nodes as mentioned in the Idun website, so you can use either of those, doesn't matter. One thing that you're not supposed to do is run computation tasks directly on the login nodes, because they are not supposed to do that. The way supercomputers usually work is they have a scheduler, and you tell the scheduler a couple of requirements and hand it over a job script that it will execute whenever it thinks it has ample resources for your job, right? Okay, so with that out of the way, and since we are logged in, we are pretty much at the same point that I showed you for the MobXterm a couple of minutes back. Now if you do pwd, which stands for present working directory, it will show you a path. This is your home space, and you can store stuff here if you want, like you can keep things here, but your main job and everything that actually that happens on the HPC actually happens here. slash cluster work slash the username. So as you can see, currently I'm in cluster slash home slash my username, but where you actually want your work to be done is in cluster, if I could spell it correctly, cluster slash work slash my username. Now if I do pwd, I am in the work space basically. Now before we move forward, there are a couple of things that we need to understand. This is not your typical Linux machine where you just go ahead and do something like sudo apt install xyz, or maybe pip install something. Don't do that, because these are basically supercomputers being maintained in a very different way. You could be using Python 3 and someone else could be using Python 3.6 on the same machine. So it would be very inconvenient if people just had all the rights to install whatever they wanted. So that is why the maintainers of these supercomputers usually use something called the module system. Modules are nothing but a group of softwares which can be loaded and unloaded on demand and on a per user basis. So these are like pre-packaged repository of softwares like PyTorch, or maybe TensorFlow, maybe GCC, CMake, you name it. So what you do is so when you need a software, you load a module, and then that software becomes available to you. For example, I'll show you. Python is a pretty standard thing to use for let's say a data scientist. If you type in Python here, you'll say that Python does not exist in this shell. I'm like, okay, what's happening? We don't have access to Python. Well, we do. So if I so now I'll be interacting with the module system first, okay? And this is not the standard way of using modules in terms of computation, but I'm just showing you what's going on. So module available will list all the available modules that you can install it. And if you'll notice carefully, it has multiple versions of the same software depending on what you want to do, if you want to use a particular version, so on and so forth, right? This is a list. This list is not really useful to us. What you want to use is module spider, and now you can pretty much look for what you want to use. So in our case, we want to use PyTorch. So I'll write module spider PyTorch, and it will find all the modules in which PyTorch is available. Here you can see there's a module called PyTorch, and there are different versions of that module available, and each one has basically a different version of PyTorch. PyTorch is also available here in TensorBoard X module or whatever it is, and it is also available in Torch Vision, this. So a couple of places. Now if you have multiple versions of the same module, it won't give you an installation instruction. In that case, what you need to do is select a version and run module spider again with that version name, module spider. And if you do that, then it will give you the exact command that you need to install this module. This basically says that, right? Of course you can use that, but I would like to use Torch Vision just because I want to. Also, you can load multiple modules at once, so you can have Torch Vision, and then you can, I don't know, you can also have this, sorry, you can have this as well if you want, but yeah, maybe not. We'll just go ahead with this. So the module is loaded. How do we know whether the module is loaded or not? We do module list, and it gives you a list of things that has been loaded, which includes Torch Vision and PyTorch. Okay. Uh, yeah. So now if I do Python, you'll notice that Python all of a sudden starts working because now it has been added to the list of installed applications basically. So now you can use it. You can also use PyTorch because that is one of the libraries installed with this module. You also have Torch Vision, which you can use, but we're not going into that right now. Once your job of the module is finished, you can do something, and you don't want that module anymore, you can do something like this. And if you do module list now, it will say that no module is loaded. That's basically the general idea of the module system. You'll soon understand why I'm talking about this in a bit. Yeah. Now let's open our work directory. And we want to go here and press OK, and it will again ask me for yeah. So now I have opened my directory here, and the best part of using VS Code over MobXterm is that you can edit your code directly. Something you can also do in MobXterm if you are an expert in Vim, but I'm pretty certain no one is. So yeah, we won't be running job 2 now because it actually runs the MNIST training code, which I think I currently don't have time to do in this video. But I've already experimented with it, works like a charm. We'll run job 1, which is rather trivial, and we need to understand this script properly and how to actually execute this script, because that is basically the main part of using the scheduler. A word of warning, don't do things like this. This will run the script directly, and this will be the exact same thing that I asked you not to do, which is running computation tasks on the login node. What you want to do is you want to use Slurm. Slurm is the scheduler that at least Idun is using, and Slurm is going to take your task with the requirements that you specify and schedule it on one of those compute nodes depending on whatever resource is available. But these instructions to Slurm are provided in this fashion basically. So you write a script, a bash script, and it will follow this the syntax basically. So the first line you can ignore. This is what tells the shell that this is supposed to be run using bash. If you don't write that line, you'll actually have to do something like this. Yeah, but again, let's not go into the technicalities. Just write this all the time, followed by some commented lines, and if you notice, they have a pattern. So sbatch is the start of the commented line. This is needed because we will be using the sbatch command to schedule it using Slurm, right? So sbatch basically reads these comments to understand the requirements that you want for the job. The first one is the time that you think your job might take. Anything more than this and your job will be killed. Nodes is the number of nodes you want the job to run on. A single node can have multiple cores. Number of tasks per node. If you're doing distributed computing or something like that, this comes in handy. We don't need this, so just keep them 1. Memory is the amount of RAM, it's 12 GB here. Job name, this will be important because this is basically the identifier for your job. So have it unique, have it written in a way that kind of makes sense. GPU resource, this will be like I have written GPU colon 1, which is I want 1 GPU. It can be 2, 3, 4, depending on what you want to do. You can also mention the name of the GPUs. This has been mentioned in one of the articles that I have linked in the blog I wrote. You can write P100, right? V100 or P40, P50, I guess. Sorry, forgot the names of the GPUs. Anyway, so you can be as specific as you want. You can put in all sorts of constraints. Output, this is the name of the log file in which all the output in the standard output will be redirected to. So anything that you print basically goes here, and this will be this file will be generated generated from the place from which you execute the sbatch command basically. So, and then you have the mail address, so this will be used to notify you about task completion, task starting, task being aborted, so on and so forth. And this is the mail type all, which basically means you'll get all the emails, start, stop, pending, etc. You can go hyper specific if you want, or something else if needed. This can be ignored. This is just for logging purpose. And then if you if you remember the way we use modules, you have to use modules here as well, because this tells the compute node what it needs to load in order to run your code. So you start with module purge, remove everything that has been loaded already, then you load the exact module that you need for your job, and then you run your code like this, and that's it. You name this, you can ignore. This is just for printing system specific values or something like that. So anyway, so now we'll go ahead and assign this to the scheduler. For that we use the sbatch, batch batch, and then the script you want your scheduler to run. And now it has been scheduled. We can use a command called sq user and your username, and it seems okay, so the job was pretty much completed immediately. Ideally what would have happened is, if the job was in pending, like it was in queue for execution but not yet executed, you would have a line here which would basically have the ID of like this ID, so that way you know that your job is still in queue. You can also kill an existing job that has been put in queue using the scancel command. It looks like this: scancel followed by the ID, so it will be this. So if it's still in queue, you will also see the ID here, job ID. Just use that ID followed by, following this scancel command, and it will be taken out of the queue. As you can see, the job completed and the output was generated. Yeah, so that is how you interact with the HPC and run your commands. And as you can see, in my basic test, we printed out the GPU that was available for this job, because that's what we that is kind of one of the requirements for deep learning tasks. So as you can see, this was a Tesla P100. Yeah, so that's basically it. You can use this file explorer to basically copy things over if you need, and also download outputs that you generate. For example, here in this, I'll just copy this PDF over to this, and as you can see, the PDF is uploaded. You can also download outputs like this, so it will ask you where you want to download, right? Anyway, so that is basically it. Feel free to ask me any questions if you have regarding the Eden cluster. It's a very powerful resource which can be used for all sorts of research. So I definitely encourage you all, if you are an NTNU student or an employee, a scholar, please make use of this amazing resource. Anyway, that's all from my end. If I find something new, I'll probably update the article. And that's it. Thanks for watching. Have a great day.